Good evening. In today's lecture, we will discuss additional sums on the topic method of induction and binomial theorem, and then we'll solve sums on the topic functions. I think we have to solve miscellaneous exercise 6. We begin with the concept of Pascal's triangle. Actually, we have already discussed this, but let us do it one more time. We have x plus a raised to 0 equal to 1, x plus a raised to 1 is x plus a, and so on. We observe that the coefficients in the above expansions follow a particular pattern as given below. Index of the binomial and coefficient of various terms. See. We also observe that each row is bounded by 1 on both sides. Any entry except the first and last in a row is sum of the two entries in the preceding row, one on the immediate left and the other on the immediate right. See, this 2 is obtained by adding 1 and 1. 3 is obtained by adding 1 and 2. This 6 is obtained by adding, in fact, they should have written in different format. 4 should have been written here. So 3 plus 3, that is 6. Okay. So this arrangement is called as Pascal's triangle. Now this is according to which result? This is according to result NCR plus NCR minus 1 is nothing but N plus 1 CR. Okay. So this is nothing but Pascal's triangle. Using binomial theorem, expand 1 plus x upon 2 minus 2 upon x raised to 4. Clearly x is not equal to 0. Now we know binomial theorem for a plus b raised to n. So I write 1 plus x by 2 minus 2 upon x as what? 1 plus x upon 2 minus 2 upon x raised to 4. So this is a and this is b. We know how to expand a plus b raised to 4. It is 4c0 1 raised to 4 plus 4c1 1 cube, that is 1 into this, and so on. But again, this is to be expanded using binomial theorem, or you may say this is simple, so we will write it directly, no problem. Same for this also. But here you will again use binomial theorem. Open all the brackets to get this as the final answer. Please don't write, because I'm going to upload this file on website. So this is how we have to find expansion of 1 plus x by 2 minus 2 upon x raised to 4. Next, using binomial theorem, expand x plus y raised to 5 plus x minus y raised to 5, and hence find the value of root 2 plus 1 raised to 5 plus root 2 minus 1 raised to 5. Now here one or two steps are omitted. X plus y raised to 5 is basically what? 5c0 x raised to 5 plus 5c1 x raised to 4y, and so on. Now for x minus y raised to 5, terms are alternately positive and negative. So when you add these terms, you get what? 2 times 5c0 x raised to 5 plus 5c2 x cube y square plus 5c4 x raised to 1 y raised to 4. So you get this. Now you have to put x equal to root 2 and y equal to 1. So if you substitute and simplify, you get 58 root 2 as the final answer. If O be the sum of odd terms and E the sum of even terms in the expansion of x plus a raised to n, prove that O square minus E square equal to x square minus a square raised to n, and so on. X plus a raised to n is what? NC0, x raised to n, a raised to 0, and so on. So on simplification, I can say that x plus a raised to n, this is the sum of even terms and this is the sum of odd terms. In fact, first part is odd, right? And the second is even. Why? Because NC0 is first term, this is third term, and so on. So x plus a raised to n is O plus E, because O is sum of odd and E is sum of even. This is number 1. What is x minus a raised to n? Terms are alternately positive and negative, right? So take minus sign common from negative terms. Second, fourth, sixth, that is even terms are negative. So x minus a raised to n can be written as what? O minus e. This is number 2. Now multiply 1 and 2. So x plus a raised to n into x minus a raised to n is what? O plus e into O minus e. Now a raised to n into b raised to n is ab raised to n. Means what? X square minus a square raised to n. What is O plus e into O minus e? It is O square minus e square. See, I think you will have to read the solution once again after the lecture. And that is why I will upload the solution immediately after the lecture. So this is the first part. Now, can I say 4OE is O plus E square minus O minus E square? I can check right hand side. It is O square plus twice OE plus E square minus. So if you subtract this, then minus O square minus minus plus twice OE minus E square. Yes, in all how many? 4OE. But this is known, this is known. So substitute. So you get the second result. X plus a raised to 2n minus x minus a raised to 2n is nothing but 4 OE. Okay. Now the third part. Squaring 1 and 2 and then adding, we get what? X plus a raised to 2n plus x minus a raised to 2n equal to this O plus e bracket square plus O minus e bracket square equal to twice O square plus e square. Okay. Yes. Prove that sigma NCR 3 raised to R goes from 0 to n is 4 raised to n. We have 1 plus x raised to n as what? NC0 plus NC1x plus NC2x square up to what? NCn x raised to n. The right hand side can be written using sigma notation as what? Sigma NCR. R goes from 0 to n, x raised to r. Now put x equal to 3 on both the sides. You get 1 plus 3 raised to n equal to sigma NCR 3 raised to r goes from 0 to n. And therefore, sigma NCR 3 raised to r goes from 0 to n is nothing but 4 raised to n. Which is larger? 1.01 raised to, this is what? 10 lakh or 10,000? Is it 10 lakh? Yes. We have 1.01 raised to 10 lakh minus 10,000 equal to. Now 1.01 can be written as 1 plus 0.01 raised to 10 lakh as it is minus 10,000 as it is. Now it is 1 plus x raised to n. It is 1. 10 lakh C0 is 1. See, 1 is written. Plus NC1. 10 lakh C1 is 10 lakh into 0.01 plus, you will notice that all the terms are positive, minus 10,000. See, this is not at all difficult. Now 10 lakh into 0.01 is what? 10,000. So 1 plus 10,000, that is 10,001 plus other positive terms minus 10,000 is nothing but 1 plus other positive terms. So this is definitely greater than 0. So this difference is greater than 0, means 1.01 raised to 10 lakh is greater than 10,000. Using binomial theorem, prove that 6 raised to n minus 5n always leaves the remainder 1 when divided by 25. Now 6 raised to n minus 5n equal to, 6 can be written as 1 plus 5. So 1 plus 5 raised to n. What is the expansion? It is NC0 means 1 plus NC1 5 plus NC2 5 square up to what? NCn 5 raised to n minus 5n as it is. Now 6 raised to n minus 5n equals 1 plus 5n. Why 5n? Because NC1 is n, so 5n plus NC2 5 square and so on. Now 5n gets cancelled with minus 5n, right? We bring this one to LHS, so this becomes what? 6 raised to n minus 5n minus 1 equal to, on right hand side what remains is nc2 phi square plus nc3 phi cube up to ncn phi raised to n. Take phi square common to get in bracket nc2 plus nc3 into phi up to this. Note that phi square is 25 and this is definitely an integer, and therefore this is definitely divisible by 25, and 6 raised to n minus 5n will be 25 into integer plus 1, and therefore 6 raised to n minus 5n leaves the remainder 1 when divided by 25. Okay, the next one, if a and b are distinct integers, prove that a raised to n minus b raised to n is divisible by a minus b. N is a natural number. Actually, this can be proved using method of induction. You can try method of induction to prove this. Now, can I write a as a minus b plus b within bracket? Yes, I can. So a raised to n is now a minus b plus b raised to n, right? Now expand this using binomial theorem. So nc0 a minus b raised to n plus nc1 a minus b raised to n minus 1 up to what? Ncn b raised to n. Now NCN is 1. So this is just b raised to n. We bring it to LHS. So a raised to n minus b raised to n equal to this. Now each contains a minus b. So take that a minus b common to get in bracket a minus b raised to n minus 1 and so on. Right? You will notice that right hand side is definitely divisible by a minus b because a minus b is a factor of that. So that shows that this is divisible by a minus b. Next one, using binomial theorem, prove that 101 raised to 50 is greater than 100 raised to 50 plus 99 raised to 50. We begin with, let 101 raised to 50 be x and 100 raised to 50 plus 99 raised to 50 be y. So it is x minus y. This is x minus y, right? Now I rearrange the terms. I write second term after the third. In fact, second term becomes third term now, but minus remains minus. Don't change the sign. Then 101 is written as what? As 100 plus 1. So 100 plus 1 raised to 50. 99 is 100 minus 1 raised to 50. Minus 100 raised to 50 as it is. Now just expand a plus b raised to n and here a minus b raised to n. Okay. Minus 100 raised to 50 as it is. Now you will notice that x minus y is 2 into this. What is 57? It is 50. So if you open the bracket, it is 100 raised to 50. Why? Because 100 into 100 raised to 49 is 100 raised to 50 only. Plus 2 into this and so on. Minus 100 raised to 50. Now 100 raised to 50 gets cancelled with this. Clearly, this part is positive. So x minus y is positive. Means x minus y is greater than 0. That is x is greater than y. But we have put x for this and y for this. Hence the result. First MCQ. In the first part, we have to solve MCQs. First one, if log of 5x minus 9 minus log of x plus 3 is log 2, then x equal to. Actually, you can say that log n minus log n and obtain an equation. But as options are given, we can say that check options one by one. So for x equal to 5, you will notice that LHS is same as RHS. So correct option is B, Bombay. Second, see if log of what? Log of log x. Initially, I will not mention the base, but it is 10. Log of what? Log of log x is 0. So log of log x must be 1 because log 1 is 0. See, I know that base is 10. Now log of log x is 1. Base is 10. Log of 10 to the base 10 is 1. So this part, log x to the base 10 must be 10. So what is x? 10 raised to 10. So correct option is B, Bombay. I repeat the solution. Basically it is log equal to 0, but log 1 is 0. So log of what? Log of log x has to be 1. I haven't mentioned the base, but it is 10. Now log of which number is 1? Log of any number to the same base is 1. See, base is 10 here, right? So this must be log x. Of course, here base is 10 again. Log x to the base 10 has to be 10. Why? Because log 10 to the base 10 is 1. Now what is x? 10 raised to 10. So correct option is B, Bombay. Now I don't understand why third sum is asked. 2 log x is 4. So log x is 2, but base is 2. So what is x? 2 square, that is 4. So the correct option is B, Bombay. Fourth one, the equation log 16 to the base x square plus log 64 to the base 2x equal to 3 has, four options are given. Now I change the base to 2. The only thing is I will not mention that. So log 16 to the base 2 upon log of x square to the base 2 means 2 log x to the base 2 plus log 64 upon log 2x, right? Log 2x to the base 2. But what is log 2x? It is log 2. But log 2 has base 2. Log 2 to the base 2 is 1 plus log x equal to 3. Now base is 2. 2 raised to 4 is 16. So 4. 2 raised to 6 is 64. So 6. Now I have put log x equal to m. 4 by 2 is 2. So 2 upon m plus 6 upon 1 plus m equal to 3. Now rearrange the terms, cross multiply and so on to get this quadratic equation which has two positive roots, 2 and 1 by 3. Can log x to the base 2 be 2? Yes. Can log x to the base 2 be 1 by 3? Yes. So two real roots. So the correct option is C, Calcutta. Right. Sum number 5, f of x is 1 upon 1 minus x, then f of fx is, now fx is 1 upon 1 minus x. So it is f of fx, it is f of this. Now fx is given to be 1 upon 1 minus x. You have to use common sense. Whatever is written here, subtract that from 1 to get denominator. And what is numerator? 1. So 1 upon 1 minus. Subtract this. Now you should know how to subtract one fraction from other. So here I have multiplied numerator and denominator by 1 minus x. So 1 minus x upon 1 minus x minus 1. So 1 minus x upon minus x means x minus 1 upon x. So ultimately we have to find f of this. Same logic. So it is 1 upon, from 1 you have to subtract this. Simplify to get x as the answer, which is given in option C. Sum number 6. F from R to R is defined by f of x equal to x cube. Then f inverse 8 is, you have to use common sense, f is cubing. So f inverse is taking cube root. What is cube root of 8? It is 2. Or you may say y equal to fx equal to x cube. So what is x? Y raised to 1 by 3, taking cube root on both sides. Now y equal to fx gives x equal to f inverse y. But we are asked to find f inverse 8. So 8 raised to 1 by 3, that is 2. Sum number 7. Let the function f be defined by f of x equal to 2x plus 1 upon 1 minus 3x. Then f inverse x is. We begin with let y be the given function, cross multiply. Because see, in original function from x we obtain y. So in inverse from y we obtain x. So we write this as x equal to. So rearrange the terms to get x equal to what? Y minus 1 upon 2 plus 3y. But y equal to fx gives x equal to f inverse y. Usually in the final answer we replace variable y by x to get f inverse x as what? X minus 1 upon 3x plus 2, which is given in option A. Sum number 8. F of x is 2x square plus bx plus c. F of 0 is 3. F of 2 is 1. Then f of 1 is. Now f of 0 is given to be 3. How to get f of 0? Replace x by 0. So that gives me 0 plus 0 plus c equal to 3. Means c equal to 3. What is f of 2? It is 2 into 2 square, that is 8, plus 2b plus c. It is given to be 1. But c is 3. That gives me b equal to minus 5. So fx becomes 2x square minus 5x plus 3. What is asked? F of 1. So it is 0, which is given in option B. Sum number 9, the domain of 1 upon step x minus x, that is the greatest integer function, is what? All real numbers minus integers. Why? Because if you consider x as an integer, denominator vanishes, but denominator cannot be 0. And that is why correct option is all real numbers except integers. So correct option is C, Calcutta. Sum number 10, the domain and range of f of x equal to 2 minus mod of x minus 5 is. See, domain is obvious. Modulus function has domain set of real numbers. 2 minus modulus again has domain set of real numbers. What is domain? Domain means set of all values of x which can be assigned. Now x can assume any real value and therefore domain is capital R. Now modulus is always greater than or equal to 0. Now in the function it is minus, so multiply by minus 1. If multiplied by negative number, inequality reverses. So greater than or equal to 0 becomes less than or equal to 0. Add 2 because what is the function whose range is to be obtained? It is 2 minus mod of. So add 2. So 2 minus mod of this should be x minus 5. Mod of x minus 5. Okay. Is less than or equal to 2. Means what is the range? Minus infinity to 2. Remember, infinity and therefore minus infinity is not a real number. So this is semi-closed interval. 2 belongs to the interval, that is belongs to the range of the function. So correct option is B, Bombay. Now third sum, find whether following functions are onto or not. I hope you remember 1 1 into and 1 1 onto. First one, f from z to z defined by f of x equal to 6x minus 7 for all x belonging to z, that is set of integers. Now f from z to z is defined by f of x equal to 6x minus 7. Now 0 is an integer. Consider f of x equal to 0. That gives x equal to 7 upon 6, which is not an integer. So though 0 belongs to integer, it has no pre-image in z. So f is not onto. Now second, f from R to R is defined by f of x equal to x square plus 3 for all x belonging to R. X square is greater than or equal to 0. So f of x is definitely greater than or equal to 3. At the most what will happen? X square will be 0. But in that case f of x is 3. Right? So what is the range? It is semi-open interval 3 to infinity. Clearly 0, which is a real number, has no pre-image in R because x square plus 3 cannot be 0 and therefore f is not onto. You can also argue that for 1 belonging to R has no pre-image. Why? Because x square plus 3 cannot be 1, cannot be 2 also, cannot be 2.99999 also, right? So this is the reason.